You know that very specific universal kind of realization you get
Well,
sometimes.
I know where this is going, yeah.
Right, like you are sitting there doing a task you have done 100 times or maybe 1,000 times. You've got your entire system down.
You're on autopilot.
Exactly, autopilot. And suddenly, someone walks by, taps you on the shoulder, points to a small icon on your screen, and just says, why don't you just click that instead?
Oh, yeah, the
You
worst.
do it, and it takes half the time, and your mind just sort of shatters because you realize you've been doing it the hard way for, years.
It is a profoundly humbling experience, honestly. You realize you've spent an immense amount of energy basically taking the scenic route,
Mm.
purely out of habit.
Yeah, that feeling is exactly where we are starting today. Welcome to the deep dive.
Glad to be here.
So our mission today is exploring this fascinating developer log from July 6th, 2026. It's a blog post titled Notes on Haskell Programming, Part 179, by a coder named Ang.
Part 179, that is dedication.
Right. And the core topic is Ang's experience using a tool called Hlint for the very first time to refactor some Haskell code.
Now, for anyone listening who just heard Haskell and refactoring and immediately assumed this deep dive isn't for them, hang on.
Yes, stick with us.
Because this really isn't about the raw syntax of a programming language. Fundamentally, this is a look at how automated tools act as an objective set of eyes.
Which we all need, honestly.
We really do. We are looking at how external systems can challenge deeply entrenched habits, regardless of whether you write code for a living or just manage a really complicated email inbox.
And the human element here is what drew me to this log in the first place.
Yeah,
Right at the beginning of the post, Ang writes this incredibly honest confession.
I love this part.
They say, after so many moons coding and tweaking with Haskell code, it never crossed my mind to explore Hlint until yesterday.
So good.
I just love that phrasing, right? So many moons. They've been in the trenches for a very long time.
The contrast there is what makes this a perfect case study. I mean, look at the title of the post. Notes on Haskell Programming, Part 179.
179.
Exactly. That number alone tells us we are not dealing with a beginner. This is someone with deep, sustained experience. They are highly invested in their craft.
Yeah.
Yet, they have this massive blind spot regarding a tool whose entire existence is dedicated to suggesting improvements for the very thing they do every day.
Well, why does that happen, though? Because, you'd think an advanced user would be the very first person searching for optimization tools.
It's a phenomenon you could call the expert's blind spot or cognitive tunneling.
Cognitive tunneling, okay.
Yeah, when you get deeply advanced in any field,
Yeah.
your focus narrows down to the complex problems you are actually trying to solve. You're focused on the domain itself.
Right, like building the software, writing the book, whatever it is.
Right. Precisely. You stop looking at the workbench. You just assume your foundational tools and your basic routines are already good enough, so you never stop to ask if there's a machine that could audit your workflow.
So after so many moons, Ang finally decides to, look at the workbench. And you'd think integrating a completely new auditing tool into a mature workflow would be an agonizing multi-day ordeal.
You'd expect a massive headache, yeah.
But Ang details the setup, and it's incredibly straightforward. They use a package manager called Stack. They run a single command, just stack install lint.
Wow, that's it.
Yep. Then they point this brand new tool at a specific code base they're working on called xfs2 ebook. They just run the command slint to scan the whole directory.
It is a remarkably low barrier to entry for something that is essentially about to grade your homework.
Let's pause on that.
Yeah.
Because if I've been working on a project for that long, running a tool that is specifically designed to critique my work sounds terrifying.
Oh, absolutely.
It feels like finally letting a professional organizer into a closet you've been randomly stuffing things into for 5 years. You just turn the knob, step back, and wince. Just bracing for judgment.
I really like that analogy. And the thing about a code base like XS2 ebook or, any system you've built over time is that it functionally works.
The closet door shuts.
Exactly. The closet door shuts, the clothes stay inside, the software compiles and runs. But a tool like Hlint isn't looking at whether the code merely functions.
What is it looking at then?
It is looking at how it functions. It's looking for the hidden inefficiencies, the cluttered boxes stacked hazardously in the back of that closet.
But how does a machine even do that? If it's not running the code to see if it breaks, how is a piece of software reading a text file and offering critiques?
That's the magic of it.
Does it just do a keyword search for bad words or something?
No, it goes much deeper than a simple text search, which is what makes static analysis tools like Hlint so powerful. Instead of just reading lines of text, the tool parses the code and builds what is called an abstract syntax tree.
An abstract syntax tree.
Now, imagine taking a sentence and diagramming it, identifying the nouns, the verbs, the dependent clauses.
Like we did in grade school.
That's exactly like that.
Yeah.
The tool breaks the code down into its structural components. Because it understands the mathematical and logical structure of the program, it can recognize patterns. It knows when you've written a convoluted structure that could easily be replaced by a much simpler, mathematically equivalent structure.
Okay, so it's not reading the words, it's reading the architecture. That makes a lot of sense. So the tool finishes this structural scan, and Ang shares the output.
Let's hear the verdict.
Well, Hlint finds 3 specific hints in the codebase. Let's look at the very first one. It points to a file called srcxs2ebookconverter.hs, specifically line 143, and it flags this finding as a suggestion.
A suggestion. So a polite nudge rather than an alarm bell.
Right, a polite nudge. Here is the code Hlint found. It's sed, tpack, s, tpack d.
Okay, let's break that down.
Yeah, to translate for anyone not staring at a terminal, this is a lambda, a small anonymous function. It takes a pair of items, an s and a d, and applies this tpack action to both of them individually.
Right.
It's explicitly saying, take the pair apart, pack the s, pack the d, and put them back in a pair.
It is a very manual, mechanical set of instructions,
Huh.
step by step.
Exactly. So Hlint reads that and says, perhaps data.byfunctor.bmap tpack t.
And that suggestion is doing something conceptually very elegant.
But wait, I'm looking at this from the perspective of a developer who wrote the original line. The original line makes total sense. I take the 2 things, I pack them, I put them back.
Sure.
Why is bimap considered more elegant? It just looks like different vocabulary for the exact same outcome.
To understand why it's better, we have to look at how higher order functions operate. The original code requires the programmer to manually wire the structure.
Okay. You are literally telling the computer how to take the tuple apart and how to stitch it back together. Bimap, on the other hand, is a tool that fundamentally understands it, is working with a 2-part structure. So it already knows the shape of the container.
Exactly. It handles all the structural logistics. You just hand it the operations, in this case, tpack for both sides, and it applies them. You stop micromanaging the data structure and start declaring what you want to achieve.
Okay, I can see how that's cleaner to write. But underneath that suggestion, Hlint includes a small note explaining the actual performance benefit.
The note about laziness.
Yes, the note simply says, increases laziness.
Laziness is a foundational concept here, especially in Haskell.
See, that is where I get tripped up.
Yeah.
Because in the real world, being lazy is usually a pretty negative trait.
Usually, yes.
If my performance review says I've increased my laziness, I am packing up my desk, why is a code analyzer actively suggesting a change? Because it increases laziness.
We have to completely redefine what lazy means in the context of system architecture. In daily life, laziness implies neglecting a responsibility, right? You were supposed to take out the trash and you didn't.
Right, avoiding work.
But in computer science, specifically in a language like Haskell, laziness means deferred computation. It means the system refuses to do a single ounce of work until the exact moment that work is absolutely demanded by another part of the program.
So it's not neglecting the trash. It's like waiting until you hear the garbage truck pull onto your street before you finally tie the bag.
Precisely. Or imagine you decide to pack your suitcase 3 days before a flight. You spend an hour folding sweaters and pants.
Okay, I'm following.
Then, the day before the flight, the weather forecast changes entirely. It's going to be a heat wave. You have to unpack the sweaters, find the t-shirts, and repack.
So you wasted all that initial energy.
Exactly. If you had been lazy and waited to pack until the morning of the flight, you would have only done the work once with the correct, most up-to-date information.
That is a great analogy. How does that actually work mechanically in the code, though? How does a computer know to wait?
Under the hood, lazy evaluation uses something called thunks.
Thunks.
Yeah, thunks. When the program hits a line of code, instead of immediately calculating the answer, it creates a thunk, basically a tiny IOU, or a promise.
Like, I owe you this calculation.
Exactly. It says, I know how to calculate this if you ever actually need it. If the program eventually prints that result to the screen, the system forces the thunk to evaluate, and the work gets done.
And if it doesn't need it?
Like if the user clicks cancel or the program takes a different logic branch, that thunk is just discarded. The calculation never happened. Zero energy wasted.
Oh, wow. So going back to Ang's code, the manual version, taking the pair apart and packing them, might force the system to evaluate those items prematurely.
Exactly. By writing out that manual lambda function, Ang might be inadvertently breaking the chain of laziness. They're forcing the system to eagerly unpack and repack that data structure regardless of whether the final packed strings are immediately needed.
But BIMAP fixes that.
Yes. By using BIMAP, Hlint is preserving the structural laziness. It allows the underlying system to handle that pair natively, maintaining those IOUs for as long as possible.
So the laziness here isn't a lack of work ethic. It is supreme calculated efficiency.
Supreme efficiency. You nailed it.
That reframes things completely for me. Finding a more elegant phrasing isn't just about making the code look pretty, it's allowing the system to do less unnecessary heavy lifting.
It's shifting from micromanaging instructions to a higher-level declaration of intent. And that theme of communicating intent, it becomes much more pronounced when we look at the next two things Hlint found.
Actually, wait, I'm noticing a shift in the tone here. Looking at the log, that first hint about BIMAP was labeled a suggestion, but the next two results from the scan are explicitly flagged as warnings.
A definite escalation.
Yeah, why does the tool escalate its language? If it's just offering optimization ideas, why is it suddenly warning Ang?
A suggestion usually implies, here's a mathematically tighter way to do this. A warning implies you are introducing unnecessary cognitive load.
Oh, interesting.
Or you're writing something that is highly likely to confuse another human being and cause a bug down the line. It's an escalation from just efficiency to actual safety.
Let's see what triggered the warning then. The second result is in that same converter.hs file, just a few lines down at line 151. Hlint issues a warning about a sorting function.
Okay.
It found the phrase sort by, flip day comparing tl.length. Hlint flags this and says, perhaps sort by, comparing data.or down tl.length.
The dreaded flip.
Yeah, it specifically wants Ang to use this concept called down.
Let's break down the original code because it highlights a very common mental gymnastic we do in programming. Sort by is self-explanatory. Comparing tl.length is also pretty obvious. We are comparing the lengths of text.
Right.
But that flip command sitting right in the middle is the problem.
What exactly is flip doing? Honestly, it sounds like a skateboard trick.
It does, yeah. So when you compare numbers or lengths, the default sorting behavior in almost every system is ascending order, smallest to largest.
Makes sense.
To reverse that, to get descending order, programmers sometimes use a command called flip. It literally takes the underlying comparison function and flicks the arguments around.
Like a mirror image.
Yeah, it reverses the polarity to trick the sorting algorithm into going backwards.
Okay, but hang on. If someone has been coding for so many moons and is on part 179 of their devlog, flip is probably deeply ingrained muscle memory to them, right? It's a standard trick.
Oh, absolutely. It's a very common idiom.
So if it works perfectly fine, why should they have to relearn a new vocabulary word like down? Why is Hlint throwing a warning over a preference?
Because of the cognitive load it places on the reader. When you, as a human, read that original code, your brain has to parse multiple steps.
Right.
You read, okay, we are sorting, we are comparing lengths. Oh, wait, I see the word flip. So whatever the normal outcome of comparing those lengths is, I need to imagine the exact reverse of that.
Oh, I see. You are forcing the human reader to manually simulate the machine's logic in their head.
Precisely. You have to run the code in your brain before you understand what the line is trying to achieve. Now compare that to Hlint's suggestion.
Using down.
Yes. It replaces the mechanical trick with a semantic declaration. Down explicitly tells the compiler, and more importantly, the next human reading the file, I want this sorted in descending order.
You don't have to simulate a flipped comparison. You just read the word down and you instantly know the intent.
Exactly. It removes a step in the translation process.
That makes total sense. It's the difference between describing a mechanism and stating your goal. Which brings us to the third hint, which is honestly my absolute favorite.
It's a great one.
This is from a different file, srcx-s2e book lexicon.hs, line 147. Another warning, Hlint found this exact line of code, 0y equals c and in c it's 9.
Ah, the classic boundary check.
Yeah, and even if you have never written a line of code in your life, you can probably read that math. It's asking, is the character c greater than or equal to 0? And is it less than or equal to 9?
Yeah.
It's literally checking if the character falls within the boundaries of those numbers. But Hlint warns against this approach entirely. It suggests replacing that entire mathematical equation with just is digit c.
Which is just a Beautiful piece of advice.
So if I'm understanding this, Aang wrote a literal mechanical translation check if this character is between 0 and 9. But Hlint is suggesting a much more direct, human-readable approach.
Just ask the question.
Right. Just ask the question you actually want the answer to. Is it a digit? It feels like the difference between giving someone turn-by-turn GPS coordinates based on latitude and longitude versus just looking at them and saying, drive to the grocery store.
That is exactly it. To use your analogy, if you give me the raw GPS coordinates, I will eventually figure out that you mean the grocery store.
Right, you'd get there.
I'll look at a map, plot the points, and arrive at the conclusion. But the mental energy required to translate those coordinates into a concept is entirely wasted. I spent my time deciphering your instructions instead of just driving to the store.
But how does a machine know that? We talked earlier about the syntax tree, so the machine knows the structure of the math. But how does an automated tool have the taste to know that is-digit is better communication?
Well, it's not that the machine has human taste or intuition. It's that the static analyzer relies on a massive library of rules written by experienced developers.
Oh, so humans put that rule in.
Exactly. Over years and years, senior programmers noticed this exact anti-pattern. They saw people writing manual boundary checks over and over again, and they realized that reading the analogic causes a tiny bit of cognitive friction.
Just a little bump in the road.
Right, so they encoded a rule into Hlint. Whenever you see a syntax tree that checks if a character is between 0 and 9, flag it and suggest is digit instead. The machine is just applying the accumulated wisdom of the entire community.
It's institutional knowledge packaged into a simple scan.
Very well put.
But it raises a point.
Yeah.
The original code with the flip command and the original code with the greater than or equal to bounds check, they work. If Aang never ran Hlint, the software would continue to function flawlessly.
True.
To use our earlier analogy, the closet door shuts.
Yes, the closet door shuts and no one sees the mess inside. But what Hlint is trying to teach here, what the warning label signifies, is that code is not just a list of instructions for a microchip.
What is it then?
Code is communication with future humans.
Oh, including the future version of yourself.
Especially the future version of yourself. When you come back to this file in 6 months to fix a bug, you don't want to spend 5 minutes deciphering your own mechanical workarounds.
Yeah, I've definitely been mad at past me for leaving a mess.
We all have. Down an is-digit, reduce the cognitive load required to read the code. When the code is easier to read, you drastically reduce the chances of introducing new errors when you eventually need to change it.
It is incredibly revealing. Aang ran one simple command in the terminal, and out popped these 3 profound hints. One suggestion to embrace laziness, using deferred computation to avoid unnecessary work and increase efficiency.
Yep.
And 2 warnings urging clarity and human readability over clever mechanical workarounds.
And we really have to admire Aang's response to receiving this critique, honestly. Think about how defensive someone could get in this situation.
Oh, very defensive.
You've been coding for so many moons, you write 179 blog posts about it, and a machine tells you your sorting logic is convoluted.
I'd be a little insulted.
Right. But in the conclusion of the log, Aang doesn't get defensive at all. They state that in an upcoming post, they will go into each of these suggestions in detail to test if they are actually useful. And they explicitly write that they hope to learn a trick or 2 from it.
That really is the mindset of a true professional. Even at part 179 of your journey, you are still actively looking for a new trick. You haven't let the expert's blind spot completely close you off from feedback.
It takes humility to admit that your established workflow might have flaws. And if we pull this back from Haskell programming to everyone listening right now, the parallels are obvious.
Oh, 100%.
We all have our own versions of the Access2 ebook codebase. We have our daily routines, our morning schedules, the workflows we use in our jobs that we've relied on for so many moons.
We do things a certain way simply because that's the way we've always done them.
And hey, they work. The closet door shuts, we get the job done.
But we get so deeply entrenched in the manual execution of our tasks. We are so busy manually checking if C is greater than 0 and less than 9 that we completely forget to ask if there's a better way.
We forget there might be an is-digit function out there.
Exactly. A simpler tool, just waiting to remove the friction from our lives. When was the last time you brought in an objective set of eyes to review the processes you run on autopilot?
It's a tough question to ask yourself.
It leaves us with such a compelling question to chew on as we wrap up this deep dive. If automated tools like Hlint can seamlessly parachute into a highly complex, mature code base, instantly spot inefficient logic and suggest improvements that champion both clarity and structural laziness.
What's the real-world equivalent?
Right. What would an offline linter look like for your own life? What complicated, deeply entrenched routines are you running every single day that could be replaced by a simpler, more direct approach?
That's a great thought.
It might just be time to open that closet door, let the organizer in, and see what you can optimize.